Imagine holding a piece of glass hundreds of thousands of years before anyone knew how to make glass. It is black, smooth, and frighteningly sharp. You didn't create it. A volcano did. This is obsidian, natural volcanic glass formed when molten rock cools rapidly. Long before furnaces, windows, or drinking glasses existed, early humans discovered that this strange material could fracture into razor-sharp edges and become a powerful tool. But here is the mystery. Nature had been making glass long before humans existed. So, how did we go from finding glass in the ground to manufacturing the glass screen you're looking through right now? The answer may begin with an accident. Before we can understand how humans learned to make glass, we need to answer a surprisingly difficult question. What exactly is glass? You may have heard that glass is actually a liquid one, that flows so slowly we simply can't see it happening. Old cathedral windows are often used as proof. Some are thicker at the bottom, supposedly because the glass has been slowly flowing downward for centuries. But that explanation is a myth. Those windows were uneven because of the way historical glass was manufactured, not because they slowly melted toward the floor. At ordinary temperatures, glass behaves as a solid, but it isn't an ordinary solid. Glass is what scientists call an amorphous solid. Imagine the atoms inside a crystal. They arrange themselves into organized, repeating patterns, almost like soldiers standing in perfect rows. Inside glass, that order never fully develops. When certain molten materials cool without crystallizing, their atoms remain arranged in a disordered structure. The material becomes rigid, but the internal structure remains unlike that of a crystal. And this strange structure gives glass remarkable properties. It can be transparent. It can be colored. It can be shaped into bottles, windows, lenses, or fibers thinner than a human hair. Yet the most surprising part is what most ordinary glass begins with. Silica, the major ingredient in many kinds of sand. Humans had walked across silica-rich sand for countless generations, but throwing sand into an ordinary campfire doesn't create a transparent window. Something was missing. And discovering what that something was would become the first real step toward manufacturing glass. So if glass begins with sand, why didn't prehistoric humans discover it every time they built a fire? Because sand alone creates a serious problem. The main ingredient in most glass is silicon dioxide, or silica. Pure silica melts at roughly 1,713 degrees Celsius, far beyond the temperature of an ordinary ancient fire. Early humans could surround sand with flames all day and still never produce the glass we recognize today. They needed chemistry. The breakthrough came from combining silica with another material called a flux. Ancient glassmakers eventually used substances rich in soda, including natron, a naturally occurring mineral found in dried lake deposits, such as those in Egypt. When mixed with silica, soda dramatically lowers the temperature needed to form glass. But that creates another problem. Glass made primarily from silica and soda isn't durable enough against water. So another ingredient becomes important: lime. Calcium-containing material helps stabilize the glass, making it far more chemically durable. Now, the basic formula was coming together. Sand supplied the silica. Soda lowered the working temperature. Lime provided stability. Heat them together under the right conditions, and ordinary-looking minerals could transform into something extraordinary: glass. Even more remarkably, the basic chemistry of soda-lime glass remains fundamental to much of the glass manufactured today. But this creates an even bigger mystery. Thousands of years ago, nobody understood silicon dioxide or calcium oxide. There were no chemistry textbooks, no thermometers, no laboratories. So who looked at sand, minerals, and a blazing furnace and discovered the right combination? For centuries, people repeated one beautiful answer. The problem is, that story probably never happened. For nearly 2,000 years, people repeated a perfect story about the invention of glass. The Roman writer Pliny the Elder described Phoenician merchants camping on a beach near the river Belus. They needed supports for their cooking pots, so they supposedly used blocks of natron from their cargo. The fire burned. The natron mixed with the beach sand. And beneath the flames, something extraordinary appeared: molten glass. It's a beautiful origin story. There's just one problem. A normal beach fire probably couldn't reach the temperatures required to produce glass this way. So the real discovery was likely far messier. The earliest known manufactured glass objects appear in Mesopotamia and Egypt thousands of years ago, and one leading possibility is that glass emerged accidentally from other high-temperature crafts. Workers making faience, a quartz-rich material covered with a glassy glaze, were already heating silica alongside alkaline substances. Under the right conditions, parts of that material could vitrify. Another possibility connects early glass to copper smelting, where intense heat could produce glassy slag as a byproduct. Either way, imagine the moment. A craftsman opens a furnace expecting one material and notices something different. Smooth, shiny, unlike ordinary stone. Perhaps nobody shouted, "I invented glass." They may not even have understood what they had created. But someone eventually realized the strange substance could be produced again. And once humans learned to repeat the accident, glass stopped being something only nature could make. Yet it wasn't about to become an everyday drinking cup. For centuries, this mysterious new material would be treated more like a gemstone. Once humans learned to make glass deliberately, you might imagine glass cups and windows appearing everywhere. They didn't. For centuries, glass remained extraordinarily difficult to produce. During the Late Bronze Age, it was a prestige material associated with palaces, elites, and long-distance exchange. Colored glass could imitate precious stones such as lapis, lazuli, and turquoise, turning something made from ordinary minerals into an object of status. At Amarna, the Egyptian capital built under Pharaoh Akhenaten, archaeologists uncovered evidence of sophisticated glassworking, furnaces, colored rods, ingots, and partially finished objects. This was no longer an accidental substance appearing inside a kiln. Craftsmen were learning to control it. They heated raw materials, produced intermediate glassy material, processed it, and reheated it to create better glass. Ancient glassmaking had become something remarkably close to industrial chemistry. And then Egypt gives us an even stranger connection to the beginning of our story. Inside Tutankhamun's famous pectoral is a yellow-green scarab carved from Libyan desert glass. Natural glass formed millions of years before Egyptian civilization existed. Think about that. Humans had learned to manufacture glass. Yet a pharaoh still carried glass created by nature. But whether natural or manufactured, glass remained expensive because shaping it was painfully slow. Early hollow vessels could require complicated, core-forming techniques and enormous skill. One bottle could take hours, and that limitation lasted for centuries. Until somewhere in the eastern Mediterranean, a glassworker discovered that a hollow iron tube and a single breath could do something extraordinary. Glass could be blown. For centuries, making a hollow glass vessel was painfully slow. Ancient craftsmen often used a technique called core forming. They shaped a temporary core, wrapped or applied hot glass around it, smoothed the surface, waited for it to cool, and then removed the material inside. The results could be beautiful, but they required time, skill, and patience. Then, around the 1st century BC, somewhere in the eastern Mediterranean, glassmaking changed dramatically. A craftsman gathered molten glass onto the end of a hollow tube. Then he did something remarkably simple. He blew. Air entered the hot glass. The glowing lump expanded into a hollow bubble. Glass blowing had arrived. Suddenly, craftsmen could create vessels far more quickly than before. Bottles, bowls, cups, containers. Glass could become thinner, lighter, and easier to manufacture in large quantities. The Romans didn't invent glass blowing, but they helped spread and expand glass production across their world. Workshops produced everyday vessels on a scale earlier civilizations could hardly have imagined. Glass was undergoing an extraordinary transformation, from luxury object to everyday material. Roman builders even began using glass in windows, allowing light into buildings while helping separate the interior from wind and weather. And Roman glassmakers achieved effects that remain astonishing today. The famous Lycurgus cup, for example, appears green under reflected light, but red when illuminated from behind, an effect linked to tiny particles of gold and silver within the glass. Humans were no longer merely making glass. They were learning to manipulate it. But after Rome, the next great struggle over glass wouldn't be about who could make the most. It would be about who controlled the secret. After Rome, glassmaking didn't disappear. The knowledge moved, evolved, and flourished in new centers. Across the Islamic world, skilled glassmakers in places such as Syria and Egypt developed beautiful techniques for enameling, gilding, coloring, and decorating glass. Their lamps, bottles, and vessels became some of the finest glass objects of the medieval world. But eventually, another city would become almost synonymous with glass: Venice. In 1291, the Venetian Republic ordered glass furnaces moved to the island of Murano. Fire prevention was an important concern, but concentrating glassmakers on an island also made their valuable knowledge easier to control. Murano's craftsmen possessed something European rulers desperately wanted: secrets, recipes, furnace technique, coloring methods, ways of producing increasingly clear and delicate glass. Around the 15th century, Venetian glassmaker Angelo Barovier became associated with the development of exceptionally clear glass known as cristallo. Suddenly, glass could imitate the clarity and beauty of rock crystal, and other European powers wanted it. France eventually recruited Venetian expertise and developed its own major glass industry. Under Louis XIV, glass became a spectacular symbol of political power. At Versailles, hundreds of mirrors filled the famous Hall of Mirrors, reflecting light, wealth, and royal ambition again and again. Glass had traveled an extraordinary path. First, nature made it. Then, kings treasured it. Romans mass-produced it. Venice guarded its secrets. And France turned it into a political statement. But the greatest revolution was still coming. Because humans were about to stop using glass merely to make beautiful objects. They would shape it into lenses, and suddenly see things the human eye had never been capable of seeing. For thousands of years, glass helped humans store liquids, decorate palaces, and look at their own reflections. Then someone discovered something far more powerful: shape glass correctly, and it can change what the human eye is capable of seeing. Eyeglasses appeared in Europe during the late 13th century. For aging scholars whose near vision had begun to fail, lenses could restore the ability to read and work with fine details. But that was only the beginning. In 1608, Dutch spectacle maker Hans Lippershey sought a patent for an early telescope. The following year, Galileo built improved versions and pointed them toward the night sky. Through carefully shaped pieces of glass, he observed things invisible to the naked eye, including 4 moons orbiting Jupiter. Glass had helped humans see beyond Earth. Then other researchers pointed lenses in the opposite direction, down, toward the microscopic world. In the 17th century, Antony van Leeuwenhoek produced powerful tiny lenses and used them to observe microorganisms. Suddenly, a drop of water contained an entire world humans had never known existed. Think about the transformation. One lens pointed toward the sky, revealed worlds unimaginably far away. Another pointed toward a tiny sample, revealed life unimaginably small. Glass wasn't simply making objects transparent anymore. It was making the invisible visible. And that changed astronomy, biology, medicine, and eventually our understanding of reality itself. But glass had one more extraordinary transformation ahead. Soon, humans wouldn't use it only to see information. They would make glass thin enough to carry information across the entire planet at the speed of light. So, who invented glass? The surprising answer is, probably no one person did. Nature had been making glass long before humans existed. Volcanoes created obsidian. Extreme natural heat transformed silica-rich material into glass. Our ancestors simply found it and learned how useful it could be. Thousands of years later, craftsmen in places such as Egypt and Mesopotamia learned to manufacture glass themselves, perhaps after noticing unexpected glassy material produced during other high-temperature processes. From there, the story became a relay across civilizations. Someone learned to control the recipe. Someone learned to shape it. Someone discovered glass blowing. Others made clearer glass. Others transformed it into mirrors. Then lenses, telescopes, microscopes, windows, safety glass, optical fibers, and eventually, the screen in your hand. Now imagine placing 2 objects side by side. In one hand, a prehistoric piece of black obsidian. In the other, a modern smartphone. They look like artifacts from completely different worlds, yet both belong to the same extraordinary story. Humans took materials as ordinary as sand and minerals and transformed them into something that allowed us to see microscopic life, observe distant worlds, build transparent cities, and send information across oceans as pulses of light. And perhaps that's the real story of glass. It wasn't born from one perfect moment of genius. It emerged through accidents, observation, experimentation, and thousands of years of improvement. Somewhere, long ago, someone noticed something strange inside a furnace. Instead of ignoring it, they looked closer.